Hey everyone! This is Peter from the Firebase team. In this video, you will learn how to use Cloud Firestore in your app on iOS. So, what is Cloud Firestore? Well, it's a horizontally scaling, document-based NoSQL database in the cloud with real-time synchronization. You can use it to store all sorts of data and keep it in sync across your users' devices. Firestore allows you to store up to 1 MB in a single document, which is roughly 1 MB. That's more than enough for most use cases, but if you need to store larger chunks of data, like a picture of a cute puppy, for example, you might want to consider using cloud storage instead. If you've watched my Firebase fundamental videos about Firebase authentication, you're already familiar with this demo app here. It's a simple app that allows users to store their favorite number. Now, this might seem overly simplistic, so I've added a couple of other things that people might want to track: their favorite color, their favorite food, their favorite city, and so on. Once I sign into the app, I can view and edit my own favorites. And since this is a multi-user app, other people can use it to store their favorite numbers, colors, cities, and so on. By default, a user's favorites are visible only to them, but if they decide to make them public by flipping this switch, other users will be able to see them as well. Here is a list of all the public favorites that people have added to the app. Let's first look at how this data is structured in Firestore. In Firestore, you store data in documents. Looking at this document, we can see that it has a number of fields, such as city, color, food, movie, and number. There is another field called isPublic, and this is a Boolean field that we use to track whether the user decided to make their favorites public or not. The user ID field is there to track which user this document belongs to. It contains the user's UID, which is a unique identifier that Firebase authentication assigns to each user that signs in to your app. To learn more about how users work in Firebase Auth, check out our Getting Started with Firebase Authentication video. So most of the fields in our document are either strings, numbers, or Booleans. But Firestore supports a lot more data types. For a complete list, check out the documentation. Each document has a unique document ID, which you can see at the top of the document view. The document ID also appears in this list in the middle of the screen. This is the collection view, and it shows a list of all the documents in the favorites collection. In Firestore, each document is contained in a collection, and you can use collections to organize your documents in a way that makes sense for your application. In this application, I've decided to store all favorite documents in a single collection. If you're interested to learn more about Cloud Firestore and how to model data, I strongly recommend watching our video series Getting to Know Cloud Firestore. Over here in Xcode, you can see how I modeled this Firestore document in Swift. Essentially, I've created a struct that contains properties for all the attributes in my Firestore document. Most of the data types in my Swift struct match the data types I used in the Firestore documents. However, you might have noticed that the color property is of type color in the struct, but I store it as a string in the Firestore document. I will explain why I did this in a moment, but let's first take a look at some basic operations for working with Firestore in a Swift application. To work with a Firebase document, we will first create a document reference. A document reference is like a path from the root of your Firestore database to the document you want to use. A path always takes the form of collection, document, collection, document, so it always has an even number of segments. First the collection, then the document, then a subcollection, and so on. So in this case, I will be working with the Peter Friese document in the favorites collection. Let's first create a document using the setData method. Code completion tells me that this method expects a dictionary. This dictionary contains a list of all the document field names and their values, so I will go ahead and type out a dictionary literal with all the field names and values. So there are two things I'd like to call out here. One, since there is no type checking, you can use setData to write any field names and any kind of data. This might or might not be what you want. On the one hand, this allows for a very flexible data model. For example, if you need another field, let's say to store the user's favorite book, you can easily add this. On the other hand, it is easy to mistype a field name, and that might result in unexpected errors later. I will show you a better way to map your documents in a few moments, but let's first look at some other operations. Once you've created a document, you might want to update some of its fields. Let's say this user has changed their mind and their favorite city is no longer London, but Hamburg. Crazy, I know. I will use this alternative way to specify the document reference. This is useful if you need to execute several operations on the same collection, but with different documents. So I will call setData on this document reference and pass in a dictionary with just this one field I want to update. But when I run this and check the result, you will notice that instead of updating just this one field, the document now contains only this field. And this is not what I intended. However, a quick look at the documentation reveals that this is the expected behavior. Using setData will replace the document with the data in the dictionary. There are two ways to update just one or more fields without wiping all the other fields. The first one is to add the merge parameter to the setData call. The other one is to use updateData. So this call here will update the food field on the document and leave all the other fields untouched. The main difference between setData and updateData is that updateData will fail if the document you're referring to does not exist yet. On the other hand, if you use setData to write to a document that does not yet exist, it will create this document for you. So far, we've made these calls without waiting for the result. But sometimes you might want to wait for the result, for example, because you need the document ID to later be able to modify a Firestore document you just created. Many of Firestore's API calls are asynchronous, so you can either use completion handlers or async await to call them. Let's use async await to create a new document and wait for the result. The first step is to make sure that we are inside an asynchronous context. Just like before, I will make a call to setData to add a document with a couple of fields to the favorites collection. Now, let's call this method asynchronously using the await keyword and assign the result of the call to a new local variable called ref. This will suspend the calling function and resume it once the call to add document returns. Let's also slap on some error handling. Once execution resumes, we can access the result of the call and print the document ID of the document reference. There are a couple of other ways to ensure your code executes in an asynchronous context, and we will later see some of them when we look at using Firestore in a SwiftUI app. So now that we've added some data to Firestore, let's see how we can read it back. Firestore supports two different ways to read data: one-time fetching and real-time synchronization. Let's first look at one-time fetching. We'll first create the document reference for the document we want to read. This is the same document we created in the previous call. Next, we'll call getDocument to fetch the document. This is an asynchronous call, and I will show you two ways to handle it. The first one is using a completion handler. Let me open the code completion on this method and then pick this overload with the completion parameter. Firestore will call this completion handler once it has fetched the document or if there has been an error. Let's deal with the error first. Even if there was no error, there is still a chance that the document we wanted to read doesn't exist. So we'll have to check for that condition using if-let. If the document exists, we can extract the data from the document snapshot. And once we've got the data, we can map it to our Swift struct. This is a pretty menial process, and as you might guess, this is not very type-safe. I will show you a better way to do this in a few moments. So far, so good. Let's now do the same, but use async await instead. I will first make sure that we're in an asynchronous context. Once I've set up the document reference, I can call getDocument. And now, when I open code completion, you can see that there is an overloaded version of the method that is asynchronous and which returns a document reference. So let me pick this and then assign the result of the call to a new local variable. Since this call might throw an error, we need to wrap it in some basic error handling. Once execution returns, we can extract the data from the document snapshot and map it just like before. Okay, I don't know about you, but having to type all this mapping code manually is no fun. Besides, it's quite error-prone, and I might easily forget to map fields that I add to my data model. So let's take a look at a better way to do this. Firestore has support for the Codable protocol, and this means it can do all the heavy lifting of mapping data from Firestore to Swift and vice versa. There are 3 steps you need to take to use it in your apps. First, import Firebase Firestore Swift in your code. Second, make sure your data model conforms to the Codable protocol. And finally, use getDocumentAs to fetch the document. To show how much code this will save you, I will make a copy of this function here and then remove all of the code that we don't need to write ourselves. We don't need all of this manual mapping code here, so let me just throw it out. Then, instead of using getDocument, I will call getDocumentAs and provide the type I want to map this to. The result will be a myFavorite type, so I can rename the local variable to favorite and then log it to the console. And with that, we've saved ourselves a bunch of typing and made our code much more readable and maintainable. Codable also works when writing documents. For example, to create a new document, I just take this Swift struct and then store it in Firestore using setDataAs. All right, these are the basics of Firestore. Let's now apply what we've learned so far to the sample application. So the first thing I want to do is save the user's favorites in Cloud Firestore. I've already made sure my data model conforms to the Codable protocol. And now you might be wondering what this addDocumentID property wrapper does. This property wrapper maps the Firestore document ID to the ID property of the Swift struct when reading a document from Firestore. This is super useful when we're making changes to the document and then want to write it back to the same document in Firestore, as you will see in a minute. In the view model, we've got a published property for the user's favorite. This is connected to the UI, so whenever the user makes a change, this model will be updated. Then, when the user taps the Save button on the UI, we will call the Save Favorite function on the view model. But before we can implement the code for saving the user's favorites to Firestore, we need to add some code so we know who the signed-in user is. This will help us make a connection between the user and their data. Let me first set up a property for the currently signed-in user. I will also add some infrastructure to make sure this property will be updated whenever the user signs in or out of the application. As you can see, I am making use of an authentication state listener for this. I won't go into the details of how this works, but if you would like to learn more about this, check out my video about getting started with Firebase authentication on Apple platforms. I've put a link in the description below. After registering the authentication state listener in the initializer, I will also set up a combined pipeline that will assign the UID of the currently signed-in user to the favorite instance that this view model manages. This is an elegant way to make sure that the favorites instance always is connected to the currently signed-in user. Great! So with this in place, I can now go ahead and implement the code for storing the user's favorites in Firestore. Since we want to store exactly one favorite document for each user, we can use the user's UID as the document ID. This is a viable strategy for cases in which you have exactly one document per user, but if you need to store multiple documents per user, you should let Firestore manage the document ID for you. However, in our case, this works well, so let's build a document reference using the path to the favorites collection and the UID of the signed-in user. Although this document doesn't exist yet, we can use the setData method to store data in it. Let's also wrap this code inside some error handling. Note that I'm using setDataFrom, which takes a codable and does all the mapping for me, and that saves me a lot of typing. So now that we saved the user's favorites to Firestore, we need to make sure to fetch them when the application starts up. For this, I've prepared a fetchFavorite method on my view model. This will be called whenever the main screen of the app appears. Thanks to the authentication state listener, the user property on the view model is always up to date, so I can first get the signed-in user's UID, and then use it to construct the path to the Firestore document that contains the user's favorite. Then I can use the getDocumentAs method to fetch the document for me. Code completion suggests to use the version of the method that requires me to use the closure to handle the result. This is fine, but I would rather use async await to make my code more readable, so I will first wrap this line inside a task to make sure I am in an asynchronous context. And now code completion shows me the asynchronous version of the method first. I'll prepend the call with the async keyword, assign the result to the favorite property on my view model, and then wrap everything in some basic error handling code. Great! So users can now save and retrieve their favorites. Let's now turn this app into a social app and allow users to share their favorites with all the other users of the app. To do this, I've added a list view to the app that I want to use to show all the favorites stored in Firestore. Here in the view model, I've set up a publish property that holds all the favorites. This property is connected to a list view, so whenever an element is added or removed to this array, the UI will be updated instantly. I've also set up two methods called subscribe and unsubscribe. These will be called when the view appears or disappears, and we will use them to activate and deactivate the real-time sync with Firestore. So let's implement the real-time sync for the favorites collection now. To implement real-time sync, I will have to add a snapshot listener. This listener will be called whenever the underlying collection or query in Firestore is changed. So no matter if a new document is added, changed, or deleted, the code inside this closure will be executed. Let's first check if the snapshot contains any documents. In the next step, I will try to map the document snapshot to a favorite struct using Firestore's codable support. Now, this might fail for a variety of reasons. For example, because some of the documents might be missing fields that are marked as non-optional in the Swift struct that I'm mapping this to. To enable me to handle all those error cases, I will wrap this call in a call to result. Swift's result type has two states, success or failure. If mapping the document was successful, I can just return the wrapped value of the result type. And if there was an error, I can decide what to do. Note that you don't have to handle this in such an exhaustive way as I show you here. This is literally just here to give you an idea of all of the different ways mappings to your data might fail. So if you're expecting different results when mapping your documents to Swift structs, take a look at the debug output in the Xcode console to see if there was a mapping failure. So this code will iterate over all the document snapshots in the result set and return an array of favorite structs. The last step for me is to assign the result of this whole operation to the favorites property of my view model. And finally, I will assign the snapshot listener registration to a private field on the view model. This allows me to later unsubscribe from the snapshot listener when my view disappears. So here in the unsubscribe method, I will implement the code for removing the snapshot listener registration. So let me run this application to demonstrate how all of this works. I will start the app on two simulators and sign in two different user accounts. So here in the simulator on the left, I've signed in as an existing user, and you will notice that the values shown on the UI match the values in the Firebase console. In the simulator on the right, I've signed in as a new user who hasn't used the app before. you can see that all the fields are still empty or show some default values. If you look at the Firebase console, you will notice that there is no document for this user yet. But when I enter some values, like this, and then hit save, a new document is created in Firestore with the values I just entered. Let's take a look at the list of favorites. And sure enough, we can see all the favorites that users of this app have saved. When I make any changes in one of the simulators, the UI updates, thanks to the snapshot listener we implemented for the list view. This also works when I make changes in the Firebase console. But there is a small problem. We are showing all of the favorites, even the ones that are not marked as public. OK, so the favorite struct has an attribute named isPublic, which determines whether or not a user is happy to share their favorites with the other users of this app. To make sure we're only showing documents that are marked as public, I will add a query to the snapshot listener. And that's it. The list view will now only show favorites that are marked as public. OK, so we've come a long way in this video. I showed you how to map, store, update, and retrieve data, and we had a look at implementing real-time sync. But there is one more thing I'd like to show you, and that is how you can fetch data from Firestore in just one single line of code. To achieve this, I will copy this line here from the view model to my list view. On its own, this line doesn't do much, but now I will sprinkle on some magic by applying the FirestoreQuery property wrapper. This property wrapper does everything we implemented in our view model, but it requires only one line of code. I can even specify a query, just like the one we used before, to make sure we only see favorites that are marked as public. And with that, we can get rid of all of this code we wrote before. Sweet! And that's all I had for you today. You now know how to connect your app to Cloud Firestore to store, retrieve, and sync data in real time. I gave you a brief overview of how to map data using Swift's Codable protocol, and we also covered the FirestoreQuery property wrapper. One important topic we did not cover in this video is security. To keep your users' data safe and secure, you should implement solid security rules for your app. We've got a bunch of resources on this topic, and I will put a link in the description below, so please do yourself and your users a favor and check these out. For more info about mapping documents with Codable, check out our documentation, which covers the basics and a couple of advanced use cases as well. And if anything is missing, please drop me a line, either in the comments below or by hitting me up on social media. I'm @PeterFries on Twitter and @PeterFries@iosdev.space on Mastodon. Thanks for watching. Stay safe, and I will see you in the next one.